Hello, this is Miss Shinners back again on the YouTube challenge, the YouTube channel. I'm here to talk to you about how to graph in Polar, and really the goal here is to get you comfortable graphing in Polar, but also to get you to understand how to use technology to help you successfully do these graphs. So I'm looking at the first homework problem on 6.3, day 2. So give me a second, let me figure out what page is that on. It is on page number 14. So if you're like, where are you, crazy lady? We're at the top of page number 14. So this graph here, because 2 and 2 are the same number, if you look back on your notes from 6.3, hopefully you see that it is going to be a cardioid. It's going to be a cardioid, so keep that in mind of the general shape that you're going for. It is going to be a cardioid, and I'm going to write that down to help my brain. Now, the next thing we want to do is make a table of values. So I make my table go up by fourths. Look on your unit circle if you need help. And then 2 pi is always going to be exactly where we started, right, at 0 radians, but I always like to include it. Anyway, all right, let's get started then. I want to show you how to use your calculator to do this. So let me open up my calculator on this. Where did it go? Here it is. All right. So the first thing you want to do is you want to press the mode key. So the same key you press to get from radian to degree, you're going to press, and if you want to just arrow down to the line that says function parametric polar sequence. And you guessed it, we're going to arrow over to polar and press enter. So we are now entering the polar domain, which is very exciting. You'll see if you press y equals, instead of seeing y, you see r equals, which is awesome, because that's what I want. So next, why don't we just type in the equation that's in front of you. So 2 plus 2 cosine, and then when you press the variable key, you'll see that it's a theta. Awesome. So now we want to get to the table. So that's going to be second graph, but before I do that, I'm going to press second window. That's going to get me to the table setup. I want to set up my table in the same way I've outlined my table by hand, right? So that means starting with 0 instead of starting with -4. I don't know why that was there, but whatever your table start was, just delete it and have it start at 0. And then that triangle table, that means what do you want your table to go up by? Well, thinking back to our own table that we just created, the table's going up by pi over 4, correct? So that's what I want my table to increase by. All right, awesome. Now that we've got my table all set up, let's press second graph. And now you'll see, I know in the angle category column, it's icky decimals, but don't worry about it. We've told the table to go up by pi over 4. So if you punch in the angle in radians, you'll get that icky decimal. Don't even worry about it. So let's copy down this table. And I round to about 1 decimal place. So let's go back to our notes here. We're just copying down that second column. And again, I get lazy, and I just round to 1 decimal. Awesome. And again, whatever we get for 2 pi, it should be the same thing we get for 0. We know that periodic tendency. All right, awesome. So the next thing you might want to do is go back to your calculator and press graph. Boy, it's broken. I can't see anything. All right, let's go to zoom then and arrow all the way down to zoom fit. So that's going to automatically zoom to get the picture. There it is. So this is my graph. It is a cardioid. I know second period had some other ideas of what this looks like, but it is a cardioid. So this is the general idea of what it should look like. But please don't just copy that down and call it a day. We want to be really careful. But that helps you realize what it's supposed to look like. But now let's graph here. So 0, 4, I go up to 0 degrees and I go 1, 2, 3, 4. I do want to see these plots pointed. 3.4 would be about right there. So on a test or a quiz, I do still want to see these plotted. Use the symmetry of the graph to guide you. And then we're back there. Okay, so there's the idea. Let's hop back over to our graph. This is what it should look like. All right, now let's just fill it in then, right? There it is. Ooh, that's actually pretty good for me. That's like the best cardioid I've ever done. Awesome. There it is. Another way to check your work on these is to use desmos. So let me show you how to do that. Just go to desmos. And go to this little tool over here, and we want it to be in polar. So we want it to look like that, and we want to be in radians. And then if you go over here and press R equals 2 plus 2 cosine, and then to get the theta, you need to go to ABC. I forgot for a second. So just to recap, R equals 2 plus 2 cosine, then go to this little keyboard, then press ABC, and you'll get the theta right there. So Desmos is nice because you can click on it. It's more interactive. Whoa. More interactive. You can zoom in, zoom out. You can plot points to make sure that you're on the right track. I meant to do that. So this is really helpful, right? There's my point. There it is on there. Then I can see it over here on my notebook, right? So remember, it's r comma theta. I made that mistake. So these are 2 great ways for you to check your work, either using Desmos or your graphing calculator. Either way, I hope you found this helpful in your polar graphing adventures. Thanks for tuning in, everybody.